So let me get into Stephany. Stephany is a senior member of the technical staff at the SCI. She received her master's degree in software engineering in 1997 and spent several years as a software developer and technical lead for companies such as Intuit, VeriSign, and Lockheed Martin before joining the SCI. While at the SCI, she has had the privilege of working with a wide variety of government and DoD organizations such as the Army, Department of Homeland Security, Veterans Affairs, and various intelligent community agencies. And her current research now is in the area of incremental software development with interest in obviously DevOps and continuous integration. So now I will turn it over to Stephany. Stephany, all yours.
Okay, great. Good morning. And today I'm going to talk to you about some new work we have in the area of architectural implications for DevOps. So first I'm going to start off with a little bit of background about DevOps before I get into the architectural implications. DevOps sort of began as a reaction, sort of like the Agile manifesto start off, to inefficiency and disconnects between development and operations groups. And these began to manifest themselves as conflict and inefficiency all across the deployment pipeline. And so we saw scenarios like the one shown in the picture here, and the DevOps community really rails against these kind of scenarios where you have situations where the release is being thrown over the fence to operations and one hand doesn't know what the other hand's doing, among various other things. So that's sort of how it got started. Here are some familiar DevOps problems that people may have seen before. Disconnects between the development and operations teams that lead to a wall of confusion between stovepipe teams, so the scenario where you're throwing the release over the wall, or disconnects between development and operations tools and processes that can cause inefficiency and rework as well. So, for example, you may find situations where people are actually creating very similar tools on both sides of that fence and not communicating and sharing information across. Another aspect of DevOps is it really helps to finish off what Agile started. So, we really saw with Agile, I think we see some real focus and improvement in the development life cycle. We saw some rapid development coming out of that through the use of Scrum and XP practices and things like that. However, due to things like lack of confidence in the deployment ability and ability to roll back, inefficient test approaches, unreliable software, various things like that, we see scenarios where the software is ready to be fielded, the features are completed, but the deployment time just takes often weeks or months. So it's just, there are issues with getting the software out the door, although it's been completed. So, as the tagline says at the bottom, there's no value gained when the software is not delivered. So a big part of DevOps sort of focuses on how do we get those improvements and continue to propagate those all through the deployment pipeline. So here are a couple informal DevOps definitions, and these aren't any that are particularly blessed in any way. These are the ones I particularly like. DevOps is a software development movement that stresses communication, collaboration, and integration between software developers and information technology professionals. Another one here that I really like is DevOps is an umbrella concept for anything that smooths out the integration between development and operations. And under that umbrella, I would include team collaboration as well as other aspects that I'm going to talk about in a moment. So the scope of DevOps is something interesting to note. So the scope for things like Agile, starts with basically the software development life cycle. It looks at the planning, coding, building, and testing phase, and continuous delivery sort of takes that to looking at how do you take that all the way to the release phase. But then DevOps focuses even beyond that, all the way from idea inception, all the way through code, build, test, release, deploy, and all the way to operations and includes sustainment. So our scope for architectural implications is as broad also. It goes all the way through the deployment pipeline. So some of the challenges that the DevOps movement is trying to solve are things like the non-collaborative stovepipe development and operations teams. That's sort of shown here by the brick wall here, as well as limited improvement within stovepiped areas. For example, situations where you have lots of improvement going on the application development side, lots of improvement going on in the ops side, maybe not improvement that's going along the whole end-to-end cycle and looking at that whole deployment pipeline. Also issues with broken feedback cycles. So process flows, everybody focused on getting the software going out the door this way, but no feedback coming back from the to the delivery team once the software has been deployed. So broken feedback loops. So what's the future vision look like? The future vision gets rid of that wall. You now have collaborative and development and operations teams working closer together. You have things like continuous improvement that goes all the way across the deployment pipeline, targeted at producing something of value to the user all the way out. This is a focus of a lot of Gene Kim's work. And effective feedback cycles within each stage. So you've got feedback loops that are going on within the stages and across. We're going to talk a lot about that. So DevOps is more than just working together, and there are there's a lot of focus on the collaboration and culture aspects, and that's very, very important. I can't say that enough. However, sometimes that gets more focus than other areas. So the way I see DevOps, there are multiple dimensions to the movement, and there are areas where all of us need to be contributing and focusing to enable it. So here's a picture of some of the multiple dimensions of DevOps. I'll just briefly touch on these because of time constraints. I can't go into them in that much detail, but the culture aspects looks at things like the development and operations collaborations, and that includes, in the operations side, that includes collaboration with security. So, DevOps as well, bringing all those teams together to develop software together. It also focuses on developers and operations have to support the releases beyond deployment. We're a full delivery team. That means the developer, as in the Google model, stays with the software, or is at least connected in some way and gets the feedback so that they can make sure they understand how their fielded software development is performing in the field. Another big focus area is automation and measurement, focusing on, automating repetitive tasks and error-prone tasks, such as, automating builds, automating tests, maintaining consistent environments through automated mechanisms, and things like static analysis and automation, as well as performance dashboards. So measurement, big focus area. Another big focus area is process and practices. So the notion of process pipeline streamlining, understanding the end-to-end pipeline, understanding where the barriers are, and removing those, as well as continuous delivery practices, as Humble's Bible, as some call it, the continuous delivery book, which covers a great set of practices that are very front and center with DevOps. And another dimension of DevOps that not everyone thinks about, but it really is pretty important, is thinking about the system and the architecture of what you're actually building, because you could make architectural decisions that actually make it difficult for you to have a rapid deployment cycle. So you have to think about, how do you architect the system so that you can achieve your deployability goals, and those include things like your test automation goals, your continuous integration goals, various other goals. You also want to think about, how do you make sure that your applications allow you to make changes very quickly without release? You don't want to have to go back to release for every small change, thinking about light binding, configuration management, configuration-driven changes, things like that. And, another example is just making sure that the system is ready so that when you push it out, you don't have problems with scalability, security, reliability, etc. So ignoring any of these dimensions can cause problems, and certainly leaning too far to one side and not the other causes problems. You want to just try to keep balance all the way across. So I talked in the last slide a little bit about the importance of architecture in supporting deployability. And that's sort of a broad, vague thing to say. And so I want to get a little bit more specific about what I'm talking about when I say that. So let me talk a little bit about how architecture can enable or impede the achievement of short feedback cycle time between some of the deployment pipeline steps. So let me walk you through an example here. So what I've done is I've taken the deployment pipeline and I've sort of just, chopped it a little bit and condensed it down a little bit so that I can get into a little bit of detail with our example. So it is a very abbreviated pipeline, so forgive me for that. But what you'll see is there's three major stages. There's the build and continuous integration stage, which is, continuously integrating and building so that you know that you have a good solid build and you get feedback on that. This stage of automated testing, and I include in that the testing of, functional testing as well as non-functional testing, unit testing, coverage testing, various aspects are sort of lumped up under here. But the notion is making sure that you're focusing on testing so that you can get a good solid set of test results that provide feedback to the delivery team within a reasonable amount of time so that they can actually do something about them. So there's a cycle here that needs to be in place. And then the automated test release cycle is the phase where you're basically pushing the software out. So those are the three phases that I have shown here. And when things are working well, you have these nice feedback loops. You have the builds going on continuously. You're getting feedback constantly, or at least in a minimum, you're getting them daily. In the feedback loop is going well. Here you have automated tests running, getting feedback quickly. When it's going well, you've got deployments going out quickly. You're getting feedback. The feedback is going back to the delivery team so they know how the system is performing in operations. So let me give you some examples of broken feedback cycles to try to articulate how architecture could impact this. So some examples of some of the things that we see are things like F1, which is shown right here, where builds take too long due to poorly managed component dependencies. So you have too many things tied together, takes too long to build, and for that reason, integration builds are slow and sometimes become infrequent, and you can't even meet the minimum requirement of trying to build at least daily. Your architecture can constrain that. With F2, the example here is that, and this maps to right here, a system doesn't have architecture interfaces for test automation. Manual tests are slow, tests are skipped, and for that reason, you actually don't end up getting some of the critical feedback you need in time to be able to keep the software moving out on the schedule that you want to move out. F3 and A and B, in this example, the architecture creates deployment complexity, and error-prone manual steps prevent the release, and so you end up with weeks or months without being able to release. And this breaks this feedback cycle, so you're not getting the feedback to the development team, and you're also not getting the fielded software out to the user, and you're not getting the feedback from the user there. So those are some examples of how architecture can, enable or impede the feedback cycles. So we just gave several examples of how architecture can enable or impede these feedback cycles. So this raises several questions. And this is the questions are sort of how we organize the rest of the talk. So one of the questions is, how do we specify deployability requirements clearly and concisely? Another question is, how do we design systems for deployability? What kind of design decisions really matter? And are there architectural tactics and patterns we might want to leverage to promote deployability? Finally, when planning work, what deployability-related scenarios and design decisions should be considered early to avoid rework? So first, let me talk a little bit about requirements for deployability. So lack of clear specification for deployability requirements leads to feedback cycle breakdowns. And this is because you don't have enough information to create concrete measures. So there's no way for you to know if you're actually staying within bounds or not. So I think it's easiest to explain this by comparing to vague requirements and then trying to compare to better, more measurable requirements. So for example, vague requirements that we hear are things like our system and delivery environment shall support continuous delivery and multiple deploys a day, just like Amazon, Google, etc. So that's pretty vague, and it also doesn't allow you to measure. What would you measure? How would you measure cycle time with something like that? And people don't even think of creating requirements for deployability. So these are the kind of things you hear. So when it comes to deployment, here's another one. When it comes to deployment, everything possible should be automated. First of all, I don't necessarily agree with that statement, but in addition to that, I would say that's also a very difficult thing to measure. We can't get concrete, we can't make design decisions to make sure that we enable those feedback loops, and we can't make process decisions very well around that either. So in the next few slides, we give examples of deployability requirements that enable better feedback across the deployment pipeline. So, like I said, well-specified requirements enable feedback cycles. And so we have several examples of deployability requirements shown below that are articulated as quality attribute scenarios. So I'll walk through a few of these, and what I've done here is just organize these by the simple pipeline steps that I showed earlier. One example under the stage of build and continuously integrate, an example of a well-specified requirement would be complete the full build within 5 minutes under peak load. And I should mention here that where these come from. So all of the data that I'm going to use to in all of the examples today comes from actual project data. So this project data actually comes from ATAMs that we have been doing, architecture, trade-off, and analysis evaluations that we've been doing since 1998. I looked primarily at the last about 8 years of data, and what I see is a trend more, especially in the most recent years, just the last 3 years, I see a trend of more of these deployability-related requirements popping up in our scenarios, popping up in our data. So this indicates to us that as more IT projects run into these problems with deployability issues, they are starting to think about how to specify these requirements. So P2, the automated testing stage, an example of a well-specified requirement there is to complete execution of unit tests suite within 10 minutes, or complete execution of incremental tests within 5 hours. Or create a build, a new system-level test with an average build time of about a day. There you can measure all of those. You can see the response measures are very clear and well specified in those examples. Under the automated release phase, some examples are things like 99% of your release is automated. That one's a little bit harder to measure and monitor. Or the team makes a change to feature X, which includes a UI and business logic change, and the deployment is pushed out within 2 hours of code test completion. So that gives us some clear measure that we can work with. And so what I've done here is I just sort of mapped these out against our feedback cycles, because I want to continue to go back to that and use that as sort of our base here to work from. The deployability requirements specified as quality attributes can provide concrete measures for designing systems to achieve cycle time. So here we can see that what these requirements do is they provide us, these are the same requirements that I showed on the previous page, but we can see here they're mapped out to where they might enable a particular feedback loop. So for example, after making a change, the build should be completed in less than 5 minutes after a commit. That basically gives us some idea of a measure we could use to measure the feedback cycle between the build and continuous integration step and the delivery team. How fast should that happen so that we can get that feedback going? Here on the this one, these that are the test automation, these map over to F2, which enable the feedback loop for completing the automated tests, and it specifies that the test should be completed within 10 minutes or 5 hours. So, this just gives you some idea of how you would use these things. And in the next step, we're going to talk about how you use these to actually design the system. So, we've just talked about deployability requirements. Now we're going to talk a little bit about design decisions that enable deployability. So again, I want to this is just my reminder slide to say that again, we drew upon real project data for our results. We went out and did a series of interviews to collect the data that we're going to use in the example decisions that we give in the next piece. And this was only, that was just a sampling of the interviews. We've done more than that, but just a sampling. So I'm going to go through some actual decisions that project teams made. And so when I do that, I want to start off by saying that there is no one-size decision that fits all, as we know. And so I don't want to leave the impression that these are the end-all, be-all design decisions that everyone should apply to their system. You have to consider your context. You have to consider trade-offs. So there are a lot of factors to consider. But it does help us to be able to understand what kind of design decisions people who are promoting deployability and continuous delivery are making, and so that we can learn from those. So as I go through, I'm going to present the design decision that the project made, and then I'm also going to talk about the trade-offs, because also whenever you make a design decision, it's important to remember that you will promote one quality and you will always have some kind of, you'll inhibit another quality. And that's just the nature of design decisions. It's not a bad thing, and it's not, if you have more pluses than minuses, that doesn't necessarily mean anything. It just means these are the things that you have to consider when you consider that design, and make those, consider those trade-offs when you decide if that's an appropriate decision for you. So the first decision I'll talk about is a decision a project team made to go ahead and divide components and allocate teams separately to promote rapid builds and tests. So basically what they did is they separated out their team, and they allocated the team to different sets of modules, and they have them sort of working in these two parallel paths. And what this does is it allows them to reduce their build time. So if they have to make a change to Team B has to make a change to the blue components, they don't necessarily have to rebuild the entire system. So it just allows them to shorten that build time a little bit. And it also allows them to promote the aspect of modifiability. You can make a change and you won't necessarily have ripple effects that affect the other components where those petitions lie. The other thing it sort of promotes is the notion of testability. So you can go in and test, and you won't have a ripple effect to the other components assigned to the other team. So it's promotes those things. One of the trade-offs with that particular decision is that when you have multiple teams assigned to two sets of paths of module development, and you've structured the code and separated in that way and assigned teams that way, you can have situations where teams will end up building the same capability. Both teams will end up building it because one side doesn't necessarily have a common view of what the other side is doing. So then you have to think about how do you mitigate against that. Not a showstopper, but just a trade-off. So here's another decision that was made, and this one was in a couple of our interviews, was to integrate the test harness into the architecture. And when I mean integrated into the architecture, I don't mean just have it sit outside and be something that calls separate interfaces, actually making changes to the application to enable things like being able to stop and start the application in a clean state. So being able to flush the cache and things like that, being able to really control the application, building the functionality in the application itself for the test harness to be able to do pretty advanced manipulation. So what this does is help shorten test duration. So instead of having to wait for a test run to complete, or wait for the caches to clear or get to a good state, you can actually call it and tell it to control it better and clear it and more quickly run your tests. So, and leave it in a clean state as well. And so some of the changes they made were to add some interfaces to support that, add the capability to start and stop, some interfaces, and also in some cases to add interfaces to legacy components which don't always have the interfaces to call something like an integrated test harness in an automated way. So this promotes testability, the ability to be able to go in and test more quickly. It also promotes modifiability. You've got interfaces, so if you go in and make a change, you're not going to have ripple effects. So it's from that standpoint, some of the changes they made for this particular decision support modifiability. And in the other trade-off, though, is complexity. So now you have added some features and functionality into your application. So now you actually have to test those features. You have to test the features that will be called by the test harness. And you also have to think about protecting that, because you want to make sure that there's no way that those features could be ever called, erroneously. So there is some added complexity. So again, there's always a trade-off. Here was another decision, which was actually to, in a tiered architecture, to actually remove web services layer and replace it with enterprise Java Beans. And I show that here in sort of a module view to give you sort of a big picture view. And the reason they did that was actually to minimize deployment complexity and time. And in the next couple slides, I'm going to get into the details of why this approach helped with that. But before I move on to that, let me talk just a minute about the benefits, the other benefits of this particular decision for this particular project. One was that it actually allowed them to reduce the amount of marshalling they were doing. So they were doing a lot of marshalling and unmarshalling of XML with the web services, and they don't necessarily have another consumer that's using those web services. So they're taking on a lot of overhead and causing, some performance latency for really not a lot of benefit. So by taking that out, they reduce that overhead. Some of the trade-offs were, again, they're doing a little bit more tight coupling. So here they're getting a little bit, tighter coupling. Before they had this nice clean separation between the web services. So that affects testability because, now you have a little bit less ability to go in and do an isolated test using a service call that's really cleanly isolated. You can still do it, but it's just a little bit, it may impact testability a little bit. Same thing with modifiability. You've got a little bit less of a layer here, less encapsulation. It's possible that a change here could have ripple effects there. You have to make sure that you put in layers to make sure to protect against that if that's a concern. So I said I was going to talk about the web services, the aspects of this decision that actually promoted deployability and helped them reduce cycle time. So these are some deployment views that kind of help you see what they did here. So before they had to update multiple application servers and web servers to make sure that the application and the services versions were in sync. So the process of releasing the software required basically putting out web app release packages to the web server, and then also pushing out web services release packages to another server that was hosting their web services. This is the way they had architected it in this particular instance. So that's a lot of orchestration, took a lot of time, kind of error prone. And so, because we've got a lot of different configurations running on a lot of different boxes. So what they did here is they actually went in and said, okay, well, if we collapse that layer, then what we can do is basically have all the boxes configured the same. We get rid of the web services hosting box. We eliminate 2. And then we basically have the rest of the release packages can be the same, can be pushed once, they can be configured the same, they can be done in an automated way, and they can all run on the, the hot and the cold boxes all the same. So it simplified their deployment strategy quite a bit to be able to do it that way. And one of the things that I think is really cool about this example is that when people traditionally think of architecture analysis, we've sort of gotten a bad rap, and people immediately think, oh my gosh, those people are going to come in and start adding a bunch of clusters and a bunch of components and a bunch of controllers and start adding stuff. Well, a lot of times, architects do that because there are performance problems or availability problems, and those are the things that they need to use to actually address it. So we get sort of that bad rap. But the reality is, if you follow, real just basic architecture principles, and you're looking at what are the driving concerns that are driving your design decisions, in many cases, you'll end up actually streamlining the architecture. So this is what happened here. We went from a lot more boxes to a more simplified architecture by looking at it through the lens of a deployability as a quality attribute. That being said, there are trade-offs here. If you could see a situation where you might have another consumer coming down the pike that might use that web service, you would need to reconsider that. So I'm not saying any of these are perfect solutions, but these are great examples of how deployability really drives some of the decision making. In this example here, this is a pretty simple example of where there were 4 web services that were basically calling the same storage mechanisms or using the same mechanisms to access storage and accessing the same storage mechanisms. So you had to actually go out and push each of the 4 web services independently for deployment. And in this particular case, it was on the client side to do that. So it was cumbersome. And for that reason, not a lot of deployments were going on. So what they did is simplified, brought that down to one service. And because they had cohesion, they were using the same data storage and the same mechanisms, then they actually could then leverage the same connection pool. Instead of having 4 separate connection pools, they went down to 1, simplifying again. And this had trade-offs where it produced releasability by allowing them to more quickly and rapidly release. It also promoted performance because they could share one connection pool instead of having a whole bunch of these competing. And then it also had trade-offs though. So in this case here, again, you're going down to a more tightly coupled architecture. When you do that, you have more chance for ripple effect. If you make a change in that service and you really mess something up, you could affect the other services as well. And same with testability. If they're completely standalone, you really can test in isolation. If they're an interface that's in a shared service, you still have isolation, but just not quite as much. So there's just trade-offs. So here again, we're going to map these design decisions to our pipeline. And so the first one, the architecture partitioning decision, this really enables the feedback loop between the build, continuous integration and build cycle, because then you can have reduced builds and keep that feedback loop going. The integrated test harness decision, this really supports this automated testing feedback cycle. You're able to test faster, you're able to test more, you're able to more quickly get that feedback to the team. And these 2 decisions support deployability, ability to get the release out there so you can get all types of feedback on it. For a minute, I'm going to just go over sort of a tiny bit of a big picture view. I'm not going to go through the whole thing because of time constraints, but I want to just see sort of where we are and sort of where we're headed and show you that. So we talked a little bit about requirements. We talked about specifying requirements as quality attribute scenarios. And then we talked about how, we can use those to drive design decisions. We talked a little bit about how quality attribute scenarios actually contain quality attribute responses that are very specific. And now I'm going to talk a little bit about how those quality attribute responses can be used to help control, or how you can use tactics to control quality attribute response measures. So you can use very granular design decisions that we refer to as tactics to actually help control and meet those design decision cycle time constraints. So here is our example where I try to do a little bit of walk the dog, where I just try to walk us all the way through. Now, I want to point out that I am very excited about our tutorial that's coming up for Saturn, and we have a lot more complex examples and a lot more detail in those. But I'm trying to give you a little bit of a smattering here to get you excited about coming. So if we start from the beginning of the feedback loop for this example, this is our good old integrated test harness example. If we start with the broken feedback loop situation where we've got the long automated testing cycle, we then have a requirement that better specifies that. Need to complete execution of incremental tests within 5 hours. The decision is this integrated test harness. Doesn't really allow us to get down to where we can determine whether we can meet this criteria. So then we look at the tactics, and these are the actual tactics that the project team used that allowed them to get down to that 5-hour window. Things like the specialized access routines, record playback, maintain interfaces, and state synchronization and resynchronization. And by applying those, then as a result, they were able to achieve this shortened cycle time, and we have some definitive way to determine whether they were in bounds or out of bounds of that. So that sort of just walks you through the tactics. Like I said, I won't be able to go through all of that, but I just want to kind of give you an idea of what these tactics do for you. So here's another example, our good friend, the modular and distributed architecture example. Here we start with our broken feedback loop, infrequent deployments, and partly resulting from the fact that you don't have frequent builds, or it's difficult to do builds. The requirement scenario is the team makes a change to feature X, and the deployment's pushed out within 2 hours. Here the design decision is to distribute and modulize, and the tactics used are increased semantic cohesion, encapsulation, maintain interfaces, and then the outcome is reduced deployment time. So I'm just trying to kind of walk full circle there. And I just love this quote here from one of our interviews that sort of brings home their driver for this design decision. If you push the whole 3 million line application every time a change is made, you're in a world of hurt. I love that. That so articulates what we're trying to achieve with that design decision. And then, so here, very quickly, I'm just going to not go through, this is kind of an eye chart, and I don't intend to go through the whole thing, but I just want you to show you, some of the tactics that we have pulled forward from the work we've been doing, gathered from project data. So the top row of this tactics tree that we've been able to put together basically represents stakeholder design drivers. So I went out and asked the question, to projects that are practicing continuous delivery that we interviewed, what are you really trying to achieve? What are your real goals, design goals? And so I was able to just kind of take those and synthesize those, and that very directly produced the top level of our tree. That's how we're organizing our tactics. And then the deployability tactics are shown here. And you'll notice here I have here that some of the tactics such as encapsulation, increasing semantic coherence, maintain existing interfaces, those types of tactics also enable test automation. So sometimes they cross into both bins. So that's sort of a big picture of the tactics we found, and these are the tactics that we'll go over sort of in the Saturn tutorial. Here are a couple that we've actually gone through. I just want to kind of show where we have been. So we talked about the modular and distributed architecture example, and that leveraged these tactics to achieve that shortened build time. And we leveraged the integrated test harness example, leveraged these tactics over here shown in blue to meet the target test time, the integrated test harness, the target test time for test automation. So that's sort of where we are. Oh, and I wanted to point out too, we didn't get to a whole bunch of stuff. So when you come to our tutorial, we will get through. There are lots of tactics that were leveraged here under the Enable Rapid Deployment and Robust Operations category. And those are exciting tactics. Most of those fall into the category of promoting performance or availability. And so we have that really, those tactics are really what allow you to balance this need for speed and rigor. Be able to focus on being able to have software that you're confident is reliable and will perform well and secure, etc. Okay, so I think I said everything there. The last question we haven't tackled yet, we've tackled the question of, how might you specify deployability requirements, and how might you make design decisions to align with that? What are examples of those and tactics? In this last piece, we're kind of looking at the question, when would you want to allocate these design decisions? We know, especially in an incremental context, there's lots of competition for things that you need to be putting in the backlog, and that includes business features, architecture features. So, how do you determine which ones are the ones that you really want to focus on? So, here we suggest, in our, that in cases where the structure of the architecture is impacted by a decision, it really makes sense to consider those early, of course. And so examples are examples like the reworking example that we gave of the taking out the web services layer. While, that wasn't the worst change ever, it actually, was pretty significant restructuring of the architecture, certainly restructuring of the infrastructure. So where you can see the writing on the wall, where you're going to want to change component structure or things like that, those are the ones you want to kind of think about early. So in this talk, as we wrap up, we've shared an approach for describing deployability concerns as architecturally significant scenarios. We've described how to apply trade-off analysis to make deployment-focused design decisions to support deployability. We've talked about leveraging tactics to help us control deployment-related response times and what the relationship is between those quality attribute scenario measures and those tactics that you're using to make sure that you're keeping those cycle times going and you have a way to measure and make sure that you're staying within bounds. Some of the work to be done is to collect more examples of more scenarios, design decisions, and tactics. Expand and further validate the deployment tactics tree, deployability tactics tree, and apply deployment tactics to help teams reduce deployment cycle time and enable feedback cycles across the deployment pipeline. So, if you'd like to get involved, there are a couple opportunities. We have the guest editor on a IEEE Software Magazine special issue on release engineering. And so I very much encourage, if you have some topics that you would like to submit, we very much encourage you to submit those. We've got Saturn coming up, which is what we're really excited about. And that is coming up, like Linda already told you the dates for that, but Portland, Oregon. And then we have a tutorial on architecture tactics to reduce deployment cycle time. And we also encourage people, if you're interested in getting involved or, being interviewed for some of these practices, we would love to, contact us, reach out. We'd be happy to hear from you.
Okay, we got lots of great questions for Stephany, so we're about to put her on a hot seat for Q&A for a good 10 minutes. And also give Linda Northrop is still in the room with us. We have one for Linda, so we'll give you some time, just a heads up that one may be coming your way too, Linda. So first question for Stephany. If ops was involved in the agile development process, wouldn't this help solve the missing feedback problem? And this was from Rose.
If ops is involved in the agile
development process, wouldn't this help solve the missing feedback problem?
Well, yeah, it certainly helps with the communication aspects. I mean, I think that a huge part of the problem is definitely getting the teams working together and being involved in making design decisions together. That's of critical importance, and we see all kinds of patterns for doing that. Ideally, if you can bring the teams together and kind of have a unified team, great, but other models of being able to bring the operations folks to the development side and vice versa certainly help. It won't solve the feedback problems because it will solve some feedback problems in terms of process. What's wrong with the process and why aren't things working? But you to solve the types of problems that I'm talking about here, you really have to be able to understand how the architecture can actually impede your ability to release quickly and build quickly and things like that. And so in order to do that, you need to understand, how do you develop those measures, and then how do you architect the system, and then how do you measure and monitor those. I would agree heavily, though, that when you get to the point where you are measuring and monitoring the effectiveness of that process, you should be doing it together. You should be collecting that data together. You should be looking at the data. You should be deciding what those scenarios are together. And so, I agree. It helps immensely. It doesn't solve everything.
Okay. Next from Juan asking us, DevOps looks like ITIL, ITIL. What's the difference between the two, if you're familiar with ITIL?
Yeah, ITIL, basically it has a sort of a process framework, set of process and practices, and in the last few versions, it's gotten closer to looking more like what DevOps is pushing. But I think there are some pretty significant differences in just the way that the approach. One of the approaches is basically the deployment, the streamlining. Stepping way back and looking across the entire deployment pipeline, figuring out where the barriers are, and then going after those barriers. That's an approach that's advocated by Gene Kim and in the DevOps space very much. And I think that kind of thing can't be prescripted. You can't say, well, this is the practice that will fix that. It's a matter of doing the work to figure out what are the barriers. How do I figure out how to go after that? What do I do to determine what the cycle time requirements ought to be, and then how do I target that? So that's
okay, great. From Robert asking, what is working for scalable agile development? For example, how about the SAFe framework?
Oh, okay. I guess I don't want to judge on whether the SAFe framework. I've been through that. I know that pretty well. I don't want to judge whether that's working or not. I think what I will say is that there's some very common thinking that underlines both. One of them is lean thinking, the notion of eliminating waste, identifying what is your critical path to success, and making sure that you're identifying how do you deliver value and what do you do to deliver value all the way through the chain. Those kind of things are prevalent through SAFe and are reiterated heavily in fact, so there's a DevOps module by Alex, I can't remember his Yamakin or something, but it's excellent in there. But I won't say whether it's working because I shouldn't say.
Understood. Okay, next question from Michael asking, have you seen DevOps requirements written in any DoD or Army RFPs?
I guess I shy away a little bit from answering that too directly because I haven't seen all of the RFPs and I worry that I might have a limited view. I do see RFPs, but I don't see all of them. What I can tell you is that many of the organizations that were in our ATAM analysis are government and military and other types of organizations. And they have these types of requirements. That's where we got these examples. And so I know that there are some IT programs that are thinking about deployability. Whether I've seen these in all of the government, right. I couldn't say.
Okay, Bob, this is kind of a comment. Maybe it'll trigger a comment back from you. It may be helpful to differentiate development environment architecture from deployed target architecture, and how development architecture is used to optimize target architecture.
Yes. No, I agree with that. I think that's a great comment. And I wished I had more time to sort of segregate those two out, because I know you're right. There is certainly aspects of release engineering that, and I'm involved in that as well, which focus on, okay, how do you architect? How do you deal with infrastructure as code? How do you architect the systems that are actually going to support the development environment and the application, where the application will be running and how you push it out. And then there's the application itself that you have to deal with. And you're right. I mean, clearly specifying the boundaries and being clear about that is a really good criticism. I agree.
Okay, next from Depender asking, and this was back from a couple slides. Does that mean tightly coupled architecture is preferred over loosely coupled?
So the answer is it depends.
Yeah.
So if you take away anything, from this, it is that depending on what quality is important to your stakeholders, that will drive your design decisions. So a tightly coupled architecture, when you are calling components very closely together, you're really almost directly interfacing or connecting. That's a great strategy if you have performance requirements where you really have to keep your latency very low because you don't have the overhead of an intermediary. Loosely coupled architectures are very helpful if you have multiple service consumers or you have situations where you want to be able to do things like testing and be able to call isolated services like microservices. So I don't want anyone to take away the examples here as like this is take this and this is what we should do. What they're supposed to be are examples of how if you put on the deployability hat and you think about that as a quality attribute, what might that drive you to do? What kind of design decisions might you make to promote that? So there's never any tightly coupled over loosely coupled. There's always trade-off.
We'll give you a quick break. We have Linda mic back up, so we'll get back to her question that came in right at the end of her presentation, asking if you can define the tactical edge. How does the SEI have a definition of that? What does that mean for our non-DoD folks?
Yes. The tactical edge really is, as I described it, the environment in which someone is working tactically to perform a task and relying on information coming from something on their person, like a smartphone or some sort of device on their person. So just picture someone who is working in the mudslides right now in the state of Washington. That person could be, an average volunteer from the community. The person could be a firefighter. The person could be a medical emergency personnel. And they would be searching, canvassing the area, looking for, hopefully, survivors, looking for clues, and they would need to communicate with one another. They would need to triage situations that arise. They would need to bring in local equipment, and those sorts of situations require them tactically to respond very quickly and with as much information and coordination as possible. So any situation that is similar to what I've just described is what we call the tactical edge. Though the name has sort of a militaristic connotation to it, we see that lots of people are on the tactical edge, whether they're MDs in remote environments or people who are part of a fire or police or a volunteer squad in an emergency situation.
Okay, we got a minute left. I'd like to get two more questions for Stephany and Linda. You might be able to chime in for this one too, but we'll see. Is asking from Mohan asking, is there a practical ATAM use case, something related to large-scale distributed technologies, someone like Netflix, Facebook, Amazon, anything of that nature?
A
practical ATAM.
ATAM use case?
Yeah.
Well, I mean, we in the ATAMs, basically, we go out and we get an understanding of what the architecture decisions were made, and then we understand what the driving scenarios are, and then we compare those to make sure that we have an understanding of where they are. I'm not sure I understand in terms of the ATAM. Maybe he's asking, are they large scale?
Maybe have any of those large technologies done in ATAM?
Yeah. So
I think maybe the question is there actually a use case of the ATAM in a situation where the system is, much as I described, a large distributed, decentralized system, and we have done some sort of a modified ATAM in those situations, but quite frankly, we found them challenging because the ATAM is predicated on getting people in rooms and being able to beat the architecture up in the presence of the architect. I will be speaking at Saturn about an effort that I'm working on where the developers are distributed and the architecture is for a system that doesn't die. It has to continuously live, and so we really can't take it down and evaluate it and fix it back up and put it back up again. And what we've done is use the ATAM principles, although we have incorporated some new distributed technologies and some actual machine learning techniques to lend transparency to the decisions and the evaluation process. So the ATAM vanilla out of the book applied to an Amazon system, I would have to say no, although we know that because the ATAM was written up and described and is being used all over the world, we have no idea what other people might be doing with it. The SEI has not done such a use case.
Now, in terms of the mechanics of specifying non-functional requirements, there are pretty detailed examples in Jez Humpel's book in the section on testing non-functional requirements that refer to ATAM and describe how it's been applied, from his perspective in some of those industry, some of those projects.
Great. And I think one more we'll squeeze in, and I think it can be a quick answer from James asking, will the SEI be doing a report on deployability tactics? Seems like a lot of good stuff here that applies across the architecture practice.
Yes, and so we did submit a paper to the dependability and security workshop. So we've written the paper with these results in it, and so hopefully that'll be published too.